Welcome, everyone. I'll state it again in case anybody wants to run to a different talk. This is not the immutable talk. This is a different one. So this is about bounded context and domain-driven design topic. And this is about a case study of, we'll say, a semi-real developer figuring out a bounded context in his application, a large monolithic application. All right, that's me. I'm Jim. I'm a developer. I work for a local consulting company, HMB. I've been doing .NET development for about 15 years. I've had the opportunity to play kind of different roles, from architect to developer, scrum master. I enjoy learning new things, and that's how you would find me out on the interwebs. So what are we talking about today? We're going to talk about what a bounded context is. We're going to talk about what problems a bounded context can be applied to help solve some complicated issues. And then we're going to get to the case study part, and finally, takeaways, things to learn from identifying those bounded contexts. All right, so when I kind of pitched this idea to my peers and started talking about a bounded context, I'm like, oh, let's just dive in. We'll talk about how we get into the business, figure out what all the words mean in bounded context. And they go, what's a bounded context? So we're going to start off with some simple kind of definitions. This whole talk is not a lot of text or reading, but to start off with dictionary definitions, we're going to have to read a little bit. So a boundary, as its definition implies, is real or imagined point or limit that indicates where two things become different. So you can think of this as physical and abstract. We'll talk about some physical boundaries. Think about an ocean that separates countries, like the United States or the UK. Right? That's a boundary that separates two things. Got mountains in Europe. It's a good way to divide up, I don't know, Italy from Switzerland, big mountain range. In our day-to-day lives, we have cubicles that separates us from our coworkers. In more of the abstract, think about departments, right? You're grouped together, technology versus, let's say, accounting, right? Those different departments provide boundaries that separate two different things. So what's a context? Well, a context is background, environment, framework, setting, or situation surrounding an event or an occurrence which helps explain its full meaning. It's really extra information around the words that we're using that give them more meaning, right? Added value, added understanding because of where it's placed. Let's take an example of a context. Tim concentrated, contorted his face while he created a tweet. Most of us being in the technology space would assume that the next sentence would be something like, we were all amazed at how insightful and concise his tweet was. But suppose for a second that the follow-up sentence was, we were all amazed by the sound coming from his face. Right? Those different contexts give a different meaning to the word tweet. Imagine, if you will, two different people. One from a faraway land, the UK, and another here in the United States. Would you like to go to a football match? Why, yes, I would. I would like to wear my lucky Buckeye pants. Pants? Okay, I'll bring some pencils and paper and a big rubber to the game. So what's going on here? Right, we kind of have a mismatch in understanding. To start off, right, football over there means something than football over in the United States. The cultures have been separated by a boundary, and so they each have their own context. If you were to go over to the UK and go to the office and be like, hey, check out my cool new pants, your coworker might call HR. Over in the UK, pants is underwear. You really wouldn't want to be showing your underwear off to your coworkers. I mean, you might, but HR might have a problem with that. And then kind of the last one, obviously, rubber in the United States means something specific. In the UK, that's an eraser. So we have a boundary that separates these two countries that allowed them to come up with their own culture. And when we speak, right, we speak from the context of our own culture. So that's all the kind of dictionary definition stuff. Boundary, separating things, context, giving you extra information about the words that you're using. So this is Martin Fowler. If you don't know him, he's an international speaker. He wrote the Patterns of Enterprise Application Architecture. He wrote a book, Refactoring. He's not really the father of domain-driven design. That's Eric Evans. But I think Martin Fowler has a very concise definition of what a bounded context is with respect to domain-driven design. So DDD deals with large models by dividing them up into different bounded contexts, some sort of area. And then we can be explicit about the interrelationships between those bounded contexts, which is where we get into our value here. So from the perspective of domain-driven design, a boundary, again, is explicit. It keeps the knowledge inside consistent, and it separates all that noise that's going on in the outside world. And it allows us to formalize the interaction between these bounded contexts. So think about an explicit boundary. Like how do we do this in software? I'm a .NET developer, so I create projects and solutions, right? Think about it a little lower down. We talk about namespaces, right? These are virtual boundaries that we can segregate off different parts of our software from the other parts of it. So domain-driven design context is a setting in which a word or statement appears that determines its meaning. This is very similar to the dictionary definition, right? So I'm assuming most of us have used a personal finance application. Like we log into our bank website, right? And we have an account. And that account relates to our credentials that we use to log in. We also should be looking at an account that has money in it. This is on the same website. Now, as a software developer, the word is the same, account, but I certainly would not want to model my credentials account to be the same thing as my account that relates to the money. You wouldn't want the same objects to be in there. You wouldn't want to bring all the information together and be like, well, it's account, so I'm going to have one account domain object that has the username, the password, and how much money they have in their account. Right? That wouldn't really make sense. Also, it would make it very difficult to talk about an account in a meeting. You'd be like, are we talking about the credentials part, or are we talking about the money part? So a context applied to software is really how far we can stretch an idea of the model without it breaking that conceptual integrity. So again, with account, right? We can't add the idea of money to our credentials because it breaks that conceptual idea of what our credentials are as an account. This brings us to this idea in domain-driven design called the ubiquitous language. This is where people on the development team work with people in the business to come up with unambiguous definitions of words. Everyone agrees upon what the word account means. Yep, we're talking about money parts. Let's talk about accounts and debits and credits and the account numbers and all that kind of stuff. Ambiguity is really our supervillain for the ubiquitous language. If we have to continually stop and restate to whoever we're talking about, oh, nope, we're talking about the credentials part. Oh, nope, we're talking about the money part, right? If we don't have a shared understanding of the words that we're using with our business partners, then it creates a lot of headache as far as communication, and it creates a lot of chaos as a result in designing our software. So let's kind of bring this all together. So a domain-driven design, bounded context, is really models with explicit boundaries around them, where the model is unambiguous inside that boundary. Bounded context is the exploration of language as we use it with our business partners and as we design our objects, as we design our applications. All right. That was a lot to talk about two words, bounded context. So how is this going to help me? How is this going to... This is a dependency graph. This is kind of nasty, right? So if your application looks like this, then, okay, I don't really care. You know, software works. Why should I care what this looks like? Well, it's kind of hard to change. It's really hard to test. You can't think about it, right? There are too many things that are connected to too many things. So how did software get to a point like that? How do we get all these dependencies linked together? I mean, every piece of software that's ever written starts off with the first line, right? There's always that first line. It's beautiful. There's nothing else. There's only one file, right? But we get requirements, right? The system grows incrementally over time and just becomes more complex and more difficult to work with. So this is where we kind of get to the idea of if it's difficult to reason about, that is really the core of our problem. It's difficult to reason about, makes it difficult to test, makes it difficult to change. And I've kind of found in my career that developers are really kind of the limiting factor as far as the complexity. Well, it's not really developers, right? We are all just kind of humans. We're mere mortals, right? But you think about it, humans can only keep so much in their brain at one time, right? This is why phone numbers only have the number of digits that they have, because that's kind of they found out that's kind of the limiting factor of how much a human can remember. We really have tools as developers to help us deal with the complexity of software. If it were up to the computer, it doesn't care if you put 5 million lines of code in one file and execute it, right? It's just going to follow the instructions. We have all these tools, functions, classes, abstractions, interfaces, solid, domain-driven design, microservices, service-oriented architecture. These are all concepts to allow us as humans to be able to break up our problems. Fred Brooks wrote an interesting paper called No Silver Bullet. It's annoying as a developer, because I read this when I was back in college, and I feel like I'm really old because I work with all these 20-somethings. But you know, he wrote it like way before that, and he talks about essential complexity and accidental complexity. And when I was a developer coming up through the ranks, I thought, this guy's old. He doesn't know what he's talking about. I can solve all these problems. It's easy. And then as you get further along in your career, you're like, stupid old man knew what he was talking about. So accidental complexity is that complexity that we introduce as developers. And he argues in No Silver Bullet that you can really use tooling and languages to help reduce that accidental complexity cost. Think about how we used to do things before we had generics, boxing and unboxing stuff as they come out of arrays. Think about garbage collection. If anyone's done C work, they're like, yay, garbage collection. Think about the IDEs that you use. The syntax highlighting, the, hey, this is not right, this is broken, change it, right? There's lots of feedback that we get from our tools and our languages that help us address that accidental complexity. Brooks argues that the essential complexity, which is really the complexity that you can't drive out of your software because it is fundamental to the problem domain. If I'm working in a bank, and I'm writing banking software, I can't get away from the fact of how debits and credits work, of how we send information through ATM networks to move money around, right? That complexity is essential to the problem domain, and so you can't squash that complexity with new tools and new languages and new design patterns and AWS. And so bounded context helps us to solve our essential complexity because it helps us to break up our problems. It allows us to focus the models, which allows us to have better architecture. Eric Evans, who is the father of domain-driven design, wrote a nice little quote, which is, you know, total unification of a domain model for a large system is not feasible and will not be cost-effective. So how do we apply domain-driven design, and how do we use bounded contexts? It's really about decomposing problems. So you may have done service-oriented architecture before, and you would ask yourself, you know, what use cases should be grouped together to create one service? If you find some bounded contexts, that's a great way to figure out which things go together. It's using language to help define how we architect things, right, to keep them focused. Microservices, How do you define what goes in them? Bounded context. CQRS stuff, what entities should share code? Bounded context. RESTful services, bounded context. And one of my favorites, how do you create a data access layer that doesn't have a one-to-one relationship with the database structure? Bounded context. How do you figure out how to map out, oh, I got to join these tables together and come out with an entity instead of having a one-to-one map of table to object? So it should be noted that with all this glorious talk of bounded context and how much value they will provide, and once you do them, then your life will become easy. It's expensive, right? I think there's a lot of value to do it in a core business domain stuff that is core to the business that really differentiates them in the marketplace. If you're going to do it for like the throwaway app or something internal that's running in the background that moves data from here to there, it's probably not worth it to do this type of analysis to get to that point. All right. And so we begin the journey. A long time ago, in a faraway place, Colorado, there lived a developer. His name was Tim. That's Tim. This is Jim. Tim is not Jim, and Jim is not Tim. That's just for legal reasons, right? So Tim was a reasonably bright developer. It's probably because marijuana was not yet legalized in Colorado. But in about 2009, Tim was like, I'm hearing a lot of buzz around this domain-driven design stuff. So he picked up domain-driven design, tackling the complexity at the heart of software, and he started reading it. He got through the first couple chapters. He's like, all right, aggregate roots, got it. Entity objects, got it. Value objects, got it. Repository pattern, got it. I can do this. And then he implemented some software. He's like, this is still a mess, right? He got through the first 11 chapters, which, by the way, Eric Evans, like 10 years after he wrote this book, was like, man, I really should have put bounded context kind of at the beginning of the book, because everyone read the first 11 chapters, saw all the patterns, was like, patterns, I can do patterns. But one of the most valuable parts of this book is about bounded context and shared context mapping and core domain analysis stuff. So he tried out the domain-driven design stuff. It didn't really work out. But he got a new opportunity. So he packed up his stuff, moved from Colorado to Ohio to work for a healthcare company. So he shows up on a Monday morning, and he gets handed a computer and a list. These are the things you need to install in order for you to work. Visual Studio, SQL Server Management Studio, all this other stuff that needs to happen, right? This is his tool onboarding for his job, right? 2 days later, when he's done installing all of this stuff, he gets his technical onboarding. This is 2009, so it's a web forms application in .NET 3.5. You need your AJAX control toolkit, and if you go over here, we're using a 3-layered architecture. This is the technical onboarding. This is the stuff we're using to solve the problem. After a day of that, he gets his application onboarding. And this is where 5 different BAs kind of line up in one room and just kind of talk at him, right? They're like, well, this is how we test the application. And it was very much a regression-style testing of, I go to this screen, put in this information, and then I press a button, I jump over to this screen, I check to see that the result is what I expect, right? Nothing really around what the business did, just about here's how the application and I test it. Here are the rote things that I do in order to get it done. But as we all know, we are a very expensive commodity, and so we better get to work. So Tim was assigned to do some work on the flagship product, Cerberus, and he was asked to kind of make enhancements to the search page, really make it perform better and make a couple tweaks to it. And at this point, Tim has a mental model of there's some sort of file processor thing that brings in data, and then the users use the application to find some work, and then they do some work, and then they're done, right? That's as much as he understands, right? And so he gets into the code, and it looks like this. There's like 5,000 lines of markup web forms stuff, and then there's like 5,000 lines of code behind, and it's just a mess. There's multiple tabs that are all in one thing, and there's interesting magic going on. Like if you prefix it with DR, then it's going to go onto the database, and DN, then it's going to, I don't know, fly out into space and touch the sun. Tim spent some time, unraveling this mess, but he really didn't understand how the business was using it, and so he went out and he asked for some more information. And so this is kind of what they told him. All right, this whole process that the business is interested in starts off with a medical event. So this guy banged his head on a door and went to the hospital and got an X-ray and a bandage, and that created a medical claim. Now, once that medical claim is submitted, it's sent to the insurance company, who Tim works for, and they are mandated by cities and states to pay the medical claim in a certain period of time. And they mandate these things so that the insurance company doesn't hold on to it for like 2 years before they pay it. So think of this in like the 30 to 60-day range. Now, the part of the business that Tim was working for was about overpayments. So imagine for a second that somebody typed in something wrong, and instead of coding in an X-ray and a bandage on the head, they coded in head reattachment, right? We can imagine how head reattachment would be a much more expensive operation, right? In order to deal with that scenario that comes up often, right? There's either miscoding or there's a mistake along the way or whatever. The government allows insurance companies a time period to go back and collect the overpayment, the over amount that they paid the provider. So they would go back and be like, I think you coded this wrong. He just needed a bandage. I'm going to get back the money that I sent you. And that time period is like 2 years. All right, so now he understands the basics of what it is, how the business makes their money. So then he goes to his boss and he's like, all right, I need more details. And his boss said, no. He said, this is the approved communication path. There's a business owner, and the business owner runs the business unit, and they're like, aha, we shall find money and we shall acquire money. Cool. And in order to do that, we need some new software features. So I'm going to get some capital. I'm going to get $100,000, and we're going to get some developers working on this, and once they implement these features, I'm going to be more profitable. All right, cool, you can have the money. All right, so now I'm going to give it to one of my power business users. And I'm going to be like, aha, implement these features. This will be valuable to us as a business unit. All right, and then we have the business analyst who kind of works on the software side. And the business analyst is going to talk with the business user and come up with requirements. And then they're going to come up with technical requirements. And then when it's all done, they're going to give it to the developer. Now you notice kind of that this is a unidirectional line here. There's nothing coming back from the developer, right? Here are your specs. You go in the corner, you implement this, and we shall have value. Well, the mental model is the context. It's a problem for Tim. It's hard for him to design and solve the problems. He just creates more and more complex code because all he gets is put this button on this page, and when I press this button, change these fields in the database. Okay. I'll put that in, right? He doesn't have any mental model to work with. All he knows is somebody overpaid and I got to get the money back, and I don't know how this feature is going to add any business value, but I get the requirements, I implement them. So Tim finishes up his work on the massive page, and it runs a little faster, and they're like, yay, you can stay employed. And so they give him a new feature. And this is when Tim meets the Oracle. So attributes of an Oracle, right? Somebody that has access to the business users, that understands business process, and has a rough understanding of how technology works and how technology can be applied to help with the business, and has a desire to discuss how it works and how it's being implemented. So Tim's Oracle, he starts talking to the Oracle, and he starts saying, well, I feel like when I implement these things, I'm making bad design decisions, and these requirements make it really hard to do it in the software the way that the software is designed. Okay, let me go back and I'll talk to the business user about that and kind of get some feedback going. And because Tim and the Oracle created enough of a relationship, the Oracle allowed him kind of on the side to talk to the business user. And this is where we get into this type of situation. Why? Why are you doing this? Why are you doing this? Hey, Why? I don't understand. Why does this need to be here? Why do we have to put the button here, and why can't we use these values out of the database? Just go code. Just go code and leave me alone, right? So we talked with the Oracle about this, and his questions, why? And this is where he learned about developing language that was more similar to how a business person would talk. Oh, business drivers, return on investment. These are the things that are important to the business user. So when Tim would use this type of language, oh, great questions. Let's talk about what business value is going to be added from this project. What's the expected return on investment? This was all information to kind of build Tim's mental model of what it is he was doing and why he was doing it. So this project was successful, and with all great enterprise companies, when it's successful, people get promoted and don't get to work together again. Cool. All right, so at the end of this, Tim's mental model is something like this. And the dark blue stuff is kind of new, right? We kind of discover these overpayments. We gather them up together. Then we send them over to this file processor thing. People find work. They do work. And then we're going to get some money back. And we have to match that money back with those overpayments so that we can kind of balance out the account. And what he started to realize is that in each one of these kind of different verticals, there was this idea of claim. Like a medical claim is where we started, right? So there's this idea of claim, but that are a little different in each one of those separate contexts. So Tim gets promoted, becomes an architect. And as an architect, you get to work on documents like a solution architect document. That means you get to create diagrams. Yay, I'm a developer. And diagrams like, business process diagram and use case diagrams, and then, more use case diagrams, deployment diagrams, really looking at the software from a technical perspective, but trying to map out what the business does and how the software helps solve that, all via UML. And this is where Tim meets the guru. So attributes of a guru, right? Someone who's highly technical, is a sounding board for ideas, is interested in solving that essential complexity problem. I prefer someone who's a lifelong learner, someone who's interested in new ideas. So when Tim and the guru started talking, right, they each had their own experiences in the enterprise. They each understood how different business processes worked, and they each had their own mental model. But as they joined forces, through the collaboration, they started to flush out some pieces. The guru knew about some areas over here. Tim had some ideas about here. Let's mash them together and see what we get. So after that kind of work, we get to this idea of the mental model. And again, the dark blue is kind of new stuff. We identify those overpayments. Then we are really validating if they're good. And if they're good, then we want to do some collections work on it. And that's the work of like, hey, you owe me money. Give me my money. And then that kind of results in money being sent back. And then we can check on the statuses of things. But in each one of these situations, right, we have a claim, and the claim is used kind of a little differently. So kind of through this work with the guru, Tim and the guru are using the use cases, the business use cases, to validate their mental model as they continue to grow that understanding. So they would use those use cases of, I need to get an overpayment in, and I need to make sure that it's not a duplicate, and I need to make sure that when I get to the end that we have a balance of 0. Right? And so that was their integrity check on their mental models. If they came up and was like, well, is this collections part kind of like collections on a car? Well, let's run some use cases through it and see whether or not it still seems true. And if all of the use cases seem to work with the new analogy and the new mental model, good. And if they didn't, then they knew there was a problem. But this is really how they gauged whether they needed to dive in further. Either the use case would be wrong if it didn't match up, or their mental model would be wrong. But that's kind of the iteration cycle they went through. And so Tim and the guru got assigned to a new integration in Cerberus. And they had a real hard time understanding what this new integration, how it was adding any value, because it didn't fit into their mental model. And so they looked at kind of the producers and the consumers of either end of people that were using Cerberus, and they came up with a completely different mental model as far as how Cerberus was working. So they found out that there were really a bunch of these different departments that were all vying for these overpayment claims. And the way that it worked was a business unit may be interested in, let's say, subrogation. So the idea of subrogation is, let's say you get into a car accident and you get sent to the hospital. You're at the hospital. You're like, leg's broken. They fix your leg. They charge the insurance company. But somebody else hits you. And so the person that was driving that other car actually is supposed to pay for your medical bill. Now, obviously, you don't want to stop treatment to be like, did you hit them or did they hit you, right? So you just kind of charge it. And so if you identify that as a business unit, then you're the one that gets to claim that profit when it comes back. Now, there's an interesting rule with the healthcare company, which was you can only do overpayment discovery for one business unit can claim an individual claim. So they were all racing to be the first one to identify it. And so Cerberus was really the exclusion part. It was the gold standard for understanding whether or not this claim had been identified by a different department. And so those were the ones that were going to pursue the collections and payment resolution of that claim. And so, again, we see kind of each one of those different verticals as an idea of claim. But they're all different. They all have different meanings in their different contexts, right? There are certain boundaries that exist between these pieces of software. These are all departments running their own software, submitting information to Cerberus, right? There's a boundary here. A claim over here has a different meaning, right? We're trying to identify problems. Over here, we start out thinking of a claim as, does this thing exist already? Is it valid? Is it too old? Is it allowed into our gold standard of things we can collect on? And then collections has a different understanding of what a claim is. We have money we need to get back. This one says, I don't really care so much about the claim, but I got money and I need to split it up over multiple claims so that ultimately I get a zero balance. So kind of with this new understanding, the guru and Tim found ways to split up Cerberus, right? They understood more of how these processes worked and how they could divide the software differently to be more of that single responsibility, that thing that it only changes for one reason, dividing up the software in order to kind of meet that expectation. But they didn't just scrap the product that had been developed over 6 years, right? Let's be realistic, right? They created a new mental model. They implemented the integration with the new mental model in mind. They created a new valuable service for the enterprise. But as they moved forward with new projects, they incrementally moved the application towards the better mental model. All right, that's a lot of words. So let's talk about this in kind of more realistic developer terms. All right, so imagine this is your database schema. Right? We have a claim. It's got some information like a claim number, social security number, a provider. This is the person that's doing work for you. Who identified you, when it was identified, how much the total claim was worth, who the patient was. And then there's this idea of claim line items, which are, these are the codes that they would actually put in for what medical procedure was performed on you. And then we have this idea of financials, right? We expect that this is a recovery, and it was $50, so I'm going to put something over here, and ultimately you should get a credit and a debit, and they should net to zero. That's what we ultimately want. So this is how we started off designing our kind of classes, right? We had a claim, and that claim had everything in it, all of it, all together, mashed together, right? We have some extra information on the side, but we would hydrate all of these objects coming out of the ORM. So think about information that's coming into Cerberus. So we get a flat file, some CSV file. We would parse out this information into our claim and claim line items and financial line items and identifiers. And so this data-centric design, right, was really our relational data model pushed up through the layers, right? CRUD on a claim DTO, which is this giant thing of connect all of these, right? This is slightly simplified, right? I put 4 tables in. There's more like 50, right? But claim, just bring it all up. And then in this next level, all these different kind of software application parts. Right? They were all dealing with the same business layer, collections, payment resolution, kind of bringing it all together. So in each one of these situations, right, they all had an idea of a claim, but contextually, they meant different things. So we started to rename some stuff too, right? It's really an identification here. We're calling it a claim, but this part's really looking at the identification parts of it. This is really a recovery claim. It's not really a medical claim anymore. It's a, we've identified that we owe some money, and we need to recover it. Collections people, they're just like, there's a debt. I want to get my money from you. I gave you too much money. Give me my money back. And over here, it's not so much the medical claim. It's just key pieces, like source information about, yes, this claim exists, and it has an outstanding balance. Take some of this check and apply it to it. So think of it as like in AWS or something. Like you have some, you purchase some services for them. You have a database up and running. You have an EC2 instance. Maybe you're paying for some S3 storage, right? All those line items come up to a total that you owe at the end of the month. When you pay them that total amount, they go through and divide out and make sure that you're paying for the right number of line items. So imagine a bunch of medical claims at a hospital, and the hospital is going to send you back one lump check, and you got to figure out how to divvy those up. That's what the payment resolution stuff was. So it was looking for those source claims to kind of match up. So this is what it starts to look like. We start to break out that one monolithic business logic layer that was like, you know, process claim into more like process identification. Where identification looks a lot like claim, but it has its own specific data access, right, mapped to what it's most interested in. Search is the same way, right? We're interested in a smaller subset. A claim is a claim is a claim. Doesn't really map particularly well when all I'm interested in is this, right? I have to do this big heavy lift in the old monolithic model as opposed to being able to divide it out into something smaller and more concise. Collections, right? Debt. We want to know about the amount and the person we're trying to collect from. Payment resolution, kind of the same way. So Tim worked on this project for about 4.5 years. And the ultimate conclusion of that was this idea of this Prezi. So let's see if I can get this up and running. And mouse weird. Yes. All right. So this is the whole landscape. This is all the analysis that Tim got done. Start off with kind of the provider. Something happens to you. You have to see a doctor, which creates a medical claim. This medical claim travels down the highway, goes through stuff like claim pricing, claim edits, fraud, adjudication. That's making the decision. And then a medical claim gets to this really important point where they decide to pay for it. And then these claims all get bunched together, and these different departments go around and they search for this out of this big mop of medical claims. Which ones are subrogation or data mining? And they go to recovery land. So this is Cerberus. And you can think about kind of each one of these bricks is a check, a validation that we're doing. Duplicate checks and some compliance checks. And once it makes it through this exclusions wall, it becomes a recovery claim. That's all recovery. And then we send it over to collections, and we start making phone calls to the hospital. And we start sending letters. Those go back to the hospital, and there's a guy there saying, ooh, I guess we do owe you some money. We're going to send you some money back. And that's where we come in and we match up the money to the recovery claim. And it's kind of, all of that analysis work kind of came down to that. All right, so what could have been, right? It took 4.5 years to get there for Tim. So if his onboarding had been more focused on the essential complexity of the healthcare insurance domain and not so much exclusively on tools and how applications, you could click through them, right? He could have gotten to a place where he understand what the business was doing better, right? If he had met an Oracle earlier or the guru earlier, then ultimately he could have written software that was better, faster, designed well. He could have reduced the amount of technical debt that he was introducing to the application. He could have simplified Cerberus. So what are our takeaways here? A clean definition of what a bounded context is, right? Models with an explicit boundary where those models have an unambiguous meaning inside the boundary. This really helps to focus your design of your software. Onboarding should focus a lot on the essential complexity. When you're bringing in new developers, you should talk about what it is you're doing, not just the tools that you're doing. I find it very interesting in kind of my consulting career. A lot of people are very interested in you understanding Ruby or .NET or Python or JavaScript. I've found that people that are good programmers and understand a depth of a particular programming language could pretty easily shuffle over, right? It takes a couple weeks, couple months. Understanding the business that you're working in is way more important, way more important. Because once you get in there, right, yes, I know how to write a loop. Oh, it's a different language? There's a little bit different syntax. But, that essential complexity of I was working at a school district and now I'm working at a bank. Those have different problems. It takes time for people to digest all of this information, right? Onboarding for 2 days and then send them off, it's like putting a fire hose out, right? They're never going to be able to absorb all that information. People need to be able to ask questions and really iterate over the knowledge that they're understanding. Try to find people that are willing to have these discussions with you. Try to find people that have great business knowledge or great relationships with the business users and help them to refine your own mental model. Software is really a collaborative process. It's, especially at large scale, it requires open communication between kind of all of the stakeholders. Look around the people that you're developing with. Look for the ones that maybe have a lot of years experience at the client or at the place that you're working. Because software is like a soil core sample. You can see where there are environmental changes. You can see where unit testing started to become really big and where IOC containers were introduced. And when this year was when we had the mandate that 75% of the code be covered with unit tests, which is where you get interesting stuff like a unit test that initializes a class so that you can cover the constructor in your unit test. Okay. Use those use cases that are created or create the use cases to really validate your understanding of the mental model. Identify kind of those upstream and downstream kind of business users because it'll really help you define how your application is being used. Yeah. So that's pretty much it. These are kind of some interesting references, and I'll post this stuff out, this slide deck out on my GitHub repo, which I'll just go there over here so you guys can see it again. But if anybody has any particular questions, feel free to kind of come up and talk to me. But that's my contact info, and that's it. Thanks, everyone.